Okay, hello everyone, and welcome to another awesome stream, another awesome day. And today we are live again with you all to learn something new. My name is Sayam Pathak, and I'm a CNCF ambassador working as director of technical evangelism at Civo, building the next gen cloud platform and the Kubernetes service built from scratch in a cloud native way. And today I'm joined by Kyle, and we'll be talking about some amazing stuff, which is basically Docker Slim. You might have heard some buzz regarding Docker Slim recently, which was very good timing for for this particular stream. So we'll be talking about Docker Slim. We'll be talking about Slim.AI, which is really new, and it's actually in the early access phase. And also we'll be seeing like how we can improve the containers, the best practices, how we can minify the containers, minify the size of the containers using Docker Slim. So it'll be very interesting today. Stay tuned, and we'll definitely learn a lot of great things today. So some housekeeping activities, like please be nice to each other in the stream. Do not post anything which is offensive to anybody, any of the speakers, or anybody in the chat. And there's a moderator who's moderating the chat. If anything comes up, then probably you'll be the comment will be deleted, and it will be reported as flag. With that, please share the stream with your friends, and just as we do the Twitter threads, please do that. I'll just copy the link for you so that you don't have to find it. So this is the link to the YouTube stream. So make sure you share it across your socials, and let the people join and learn about some of the best practices of containers and minifying them using Docker Slim. So I think that after this particular stream, I have a gut feeling like you'll be start minifying your containers. So because that's something you can readily do, and why not do it? So once you are done with this particular session, I'm sure you will be able to do a lot of optimizations with your current containers and images. So today I'm joined by Kyle, and it's very great to have you, Kyle, on the stream. Thank you so much for tuning in and giving your time to us and explaining about Docker Slim, Slim.ai, and other cool stuff that you'll be talking about. So welcome you on the stream, and please introduce yourself to the community.
I've been building containerized applications for quite some time, and I encountered a whole bunch of problems myself, and I figured, well, that's a lot of headache, and I wanted to solve my own problems, making it easier for myself. So I came up with Docker Slim as a result. It was actually a hackathon project, but later on it gained a lot more popularity because it wasn't just my own problem. It was a problem that a lot of other people had. So it's great when you can help not only yourself but others as well. And it's probably a good idea to start with a few fundamentals, right? A few fundamentals in terms of what you need to do when you're building a containerized application, and that means creating a Docker file. So I figured it would be nice to use a simple example and Node.js applications. I think they're pretty simple, and people know Node.js or JavaScript, so everybody can relate, even if they're not Node.js application developers. So I Googled for Hello World Node.js application, and there's a nice one and simple. Its Docker file is pretty short, so it's going to be easy to get started. So just like with any application type, with any language, when you're building an application and you're creating your Docker file, you need to specify the base image, and that's what the from instruction does. You pick your base image, and in this case, we're using a standard Node image, Node version 14, which is a good starting point. Sometimes you can create custom base images from Ubuntu, Debian, or Alpine, and all of that. But that's a little bit of extra work, more advanced use cases. And then, overall, you're just defining what you have in your application. You're setting your working directory, and you're copying your application components. And in this case, you're on line number 3. You're copying the package manifest you have in Node applications and the application code itself, and then you install the dependencies, and then you say that the application runs on port 3000, and then you specify how to start the application. Seems pretty straightforward, but if you look at it, it has a number of common problems when you're dealing with Docker files. Number one is that it's good that it uses a specific version for Node.js, but it's not specific enough. It's a good idea to pin versions exactly to the version that you need and expect, so you don't get any surprises. And then when you're copying your application, and in this case, just like in many other cases, it copies everything all at once, which is convenient and nice. But one of the problems there is that you don't take advantage of caching with Docker. So every time you change the application code, you end up reinstalling the dependencies when you're building the Docker image, and that means it takes longer to build your Docker image. Another problem, another smaller problem, an invisible problem, is the way the application is started. It's nice that it's not using npm start, for example, but it's still not really doing the right thing there, because specifically with this base image, what you end up getting is an entry point shell script that starts your application. But with Docker, you end up with 2 instructions combined: the entry point instruction and the CMD instruction. They're connected together, and then it's executed like you execute a shell command. And the node image has a special Docker entry point shell script. And with shell scripts, your application usually doesn't end up getting the signals. So what does it mean? You start the command, and the most basic way to test it is to try to run that application with Docker run. You run it and then try killing that. So you do Docker run -ti and the image name. Try to kill it with Control-C. It's going to take a while to kill it. That's because it's difficult. The signals aren't getting there, and there's an easy way to fix it. You can take advantage of the built-in tiny init system that Docker supports, and that way you'll get the right thing, and the application will get the signals it needs. Another thing that's missing is the non-user for the Docker file. It's in most examples on the internet, you don't see a custom user used in Docker files, but if you're deploying your application in production, you want to use a non-root user. And for that, you either need to define a custom user in the image, or you can take advantage of the built-in users. For example, for the node base image, the default non-root user is node, which you can add using the user instruction, user -node. And when you build this Docker image, you'll actually end up with an image that's about 900 megabytes. So we have a simple hello world example that has a few lines of code, but it's almost 1 gig in size. And that's that's a common problem where you end up with really big images, and with Dockerfile that you define, you can use something like multi-stage builds to reduce the size, and depending on the application and the stuff you install, and especially if it's a compiled application, you get a much smaller image if you use multi-stage builds. With multi-stage builds, you define multiple sections where you have different steps. For example, step 1, you build the application. Step 2, you take the components from the first step, and then you copy them to the deployment image you have, and that way you can avoid generating a whole bunch of layers, because usually with the Docker file, you define each run instruction generates a layer, and with that your image gets bigger depending on the layer, and then it becomes less efficient. But the multi-stage builds, you have an opportunity to get rid of all of those intermediate layers when you use the final stage, and you just copy all of your artifacts that you need in the deployment image. The biggest problem with the multi-stage builds, though, is that you actually need to know what to copy, and for simple applications, it's not a big deal, but for more complex applications, it's a bit tricky to know what you need to copy, because sometimes you have hidden dependencies you're not aware of, and all of that. You can figure it out, but it takes time, and that's kind of one of the things you don't want to do. There's a lot of magic there, and as I mentioned, each run instruction is its own layer. And if you have more complex Docker files, and I'll use an example from one of the sample apps that I found on the internet, and I used as a Docker Slim example. So right there. So here is a nice example where you have a whole bunch of run instructions, and then you end up with different layers there, and sometimes it's not too bad. So what? I have an extra layer. But if you want to clean up your image and you want to remove files, if you have on line 15 and 16, for example, if you have the remove instructions in a separate run instruction, then you're actually not removing the files. You end up keeping the files. They're just going to be hidden, and that's it. So as for anybody new, this is probably one of the biggest gotchas, thinking that you removed the files and you optimized your image, but you actually didn't. And one of the best practices around Docker files is inlining your commands into one run instruction. So you would use 2 ampersands to inline the pip install, user add, and those 2 remove instructions. So that way it all happens in one layer, and you actually remove the data. Because if you remove the data in the layer where you generate the data, then the data will be gone. If you do it in a separate run instruction, then it'll still be there, and your image will still be big. Let's see. Right. Okay. All right. So what else? So one of the other things let me find. Okay. So with the node image, It's a standard node image with that's derived from Debian, and with Debian you usually get bigger images. So one of the optimizations and that you hear with the best practices is use a smaller image, use Alpine. So there's an Alpine version of Node.js, and if you can make it work, it's fine. But Alpine comes with its own set of gotchas because Alpine doesn't use the standard C library, and it ends up causing a lot of problems. But native modules, all of a sudden things don't work that should have, and there are other differences in terms of networking and memory management, and sometimes you end up with a whole bunch of crashes. And a lot of people who started using Alpine, they kind of go back to something else because it's just too much friction. But if you can make it work for you, if it works for your use cases, that's fine. You just need to be aware of those gotchas. And another one is that you don't get the standard packages ecosystem. And it's like with the app stores in mobile phones, it's a big deal. If you use a whole bunch of packages that you're used to, there's a good chance Alpine wouldn't have those system level packages. Let's see, and there's a lot more, but it can take a whole hour or a few hours to go over more of those best practices. But I would say using non-root users, multi-stage builds, if you want to reduce the size, and then separate and that's one thing I forgot to mention, separating your dependency installations from the application installation. So on line 3 here, we copy everything in the application, but one of the improvements there could be copying the package file first, running npm install, and then copying the application code. So that allows you to take advantage of caching. So that way you change one line in your application and you don't need to reinstall the dependencies. So the previous copy package.json and run npm install will be cached because you didn't change any dependencies, and it will take a lot less time to build a new image version. So let's see. And I mentioned multi-stage and having to know what to copy. For the big enough applications, it becomes a problem, and you still end up copying a lot, because when you don't know what to copy, you copy everything or as much as possible. And I've seen that with a lot of applications. So you still end up with a big image using multi-stage. That's where you can take advantage of what Docker Slim does, because that's one of the things it does. It figures out what you need, what your application needs, and it copies it for you. It creates an optimized image from scratch, and then based on its magic and what it learns about your application, it takes the files from the original file and it copies them to the optimized image. For example, if your application needs certificates, it'll copy those certificates for you, and then everything else it needs. We can try using Docker Slim. I'll use another application. I'll use nginx because it's pretty common and it's simple enough. Okay.
Yeah, I think that was really a nice, nice introduction to, nice primer basically to Dockerfile, and introducing some of the concepts like how it was written and what are some of the things that you can actually do, like the non-root user, the multi-stage builds, and dividing your app dependencies and the other OS dependencies, and the other things that you can do to as per the Dockerfile best practices. But like Kyle said, it can definitely take hours to discuss all of the Dockerfile best practices. But that was just the primer. The real topic that we are here today is actually Docker Slim. So Kyle, what exactly Docker Slim offers? Like what is Docker Slim, what it offers, and how we can use it?
So with Docker Slim, a lot of the problems I mentioned, it addresses them directly or indirectly. For example, using a small base image, that's a common best practice that you hear. And a lot of examples on the internet tell you, like I mentioned, use Alpine. Well, again, it's not for everybody, and you get a whole bunch of problems with it, if in some cases, obviously. And with Docker Slim, it lets you use what you have. So if you created a Ubuntu-based application image, you just use that, and you don't worry about using a smaller base image or a different operating system like distro like Alpine. You just use Ubuntu or the default Node base image, and then it's Docker Slim actually has a whole bunch of different commands, but it started by focusing on the optimization side of things. It has this build command, and let me start Docker Slim. So
Can you increase the font size if possible?
yeah, let's see. And right. Oops. Okay.
Maybe command plus control plus something like that.
Yeah, I need to exit. Preferences. Okay, where the heck is it? And where's command? Let's see.
Or maybe control shift plus.
Control.
Yep, that works. Perfect.
I don't use this terminal as much. Thank you for your help. And control.
Thanks to our community member Adarsh for telling this.
Great. Let's see, Docker Slim. So it has a whole bunch of different commands. It has the xray command that tells you what you have in your image. It has a lint command that helps you check your Docker file, and eventually it'll do the same with the container images you already built. And it has the build command that analyzes profiles and optimizes your image. So it turns your fat image into an optimized image, a minified image. And that's how it started when I first created it. And what it does, so when it runs first, it inspects the original image. It does a little bit of static analysis on the image, and then it creates a temporary instance of your container. And then when it does that, it installs a sensor inside. and then it starts the application inside of the temporary container, and the sensor is responsible for observing what happens. But the application, what it does, so it collects telemetry, and then it does a few extra things based on the additional instructions. For example, you can say, well, in addition to the application, I want to keep a few extra things there. And then it does post-processing, and it adds additional dependencies for the image, doing a little bit of static analysis on the executables and shared objects if they have dependencies. And then it takes all that and the telemetry it generated, and it sends it back to the main application. And the main application then builds an optimized image based on the information that was collected. And that's how you end up with a much smaller image. And when it does that, it uses Scratch as the base image. And Scratch is this quote-unquote virtual base image that you can't pull, but you can use that as a starting point for your application. And then it copies the files, and then it sets up the metadata for the image based on what it collected. And that's pretty much it. And then you use the optimized image just like you would use your regular image. One of the not gotchas, but one thing to keep in mind is that by default, there's a good chance you're not going to have a shell in that image, which is a good thing for production. You don't want extra stuff in production, but for debugging purposes, you might want to have shell access to the optimized image. There are ways to address that. For example, you can use a sidecar container with all of your tools, and then you just attach to the namespace for your optimized image, and then you can have a shell and all of that, everything, other debugging tools. So you get the best of both worlds. You have an optimized image, and then if you need extra tools, you can just bring them in a separate container, and then you attach to your optimized container and do whatever you need to. So let's see how we can optimize nginx. So picking one of the parameters, so target, and then here I'm going to use nginx. And that's pretty much it. That's the default mode, where you just point at the image that you want to optimize, and then you don't really need to specify any other parameters. So if we look at the output, if you look at the output, one of the things you'll see, there's this probing phase that happens. So by default, Docker Slim runs its probes, and that's a part of the kind of the analysis phase. When it starts the application, it generates traffic to the application. It interacts with the application, so it triggers different code paths in the application to see what it's doing and all of that. And the default probe, it looks for the open ports, and it tries to interact with all of them. And then one of the things it does, it crawls the pages it discovers. So if you have a web application that has a whole bunch of pages, it will crawl that. And it can also, you can add custom probe commands, and you can also point to a Swagger spec. If you have an API, you point at that API definition, and the probe will use that definition to interact with your application. There are different ways to interact with the application. You can connect to your own tests or external programs. One of the options is to invoke external programs when probing is done, so you can use additional tools to interact with your program. And then let's see what happens when we optimize the size. So the one of the lines there is showing us that we reduced the size of nginx by 12x. We went from 133 megabytes to 11 megabytes, which is not bad. And one of the other things Docker Slim does, it generates a number of artifacts when it optimizes the image. One of them is the dockerfile.fat file. It's kind of a reverse engineered Docker file for your original image. A lot of times when you deal with the third-party images, you don't know what you have, and that kind of gives you visibility. So it helps you make a decision whether or not you want to use it or not. And then it also generates a couple of different profiles. The most common tested and used profile is the seccomp profile, and seccomp is a way to. It's kind of like a lightweight firewall for syscalls, where you say, "Hey, I want to allow or disallow those syscalls in my application," and that way you reduce the surface, the kernel surface for your application. So if there's a vulnerability in one of the syscalls that's not commonly used, you can easily disallow that, and now you made it possible to have a safer environment, and that way the application, if it's a malicious application, it won't break out, or if it's exploited and all of that, it won't break out. It's not perfect, and by default, with Docker, for example, you end up with a default seccomp profile that blacklists some of the kind of unsafe syscalls that are okay to block, but a lot of syscalls are still allowed. And with Docker Slim, it actually generates a whitelist, so you can so it has the syscalls your application needs and nothing else. And it's a long discussion about whether or not deny lists are better than the allow lists, and vice versa, and pros and cons for each. But in general, ideally, you want an allow list that only allows the stuff that your application needs. That's kind of the holy grail that you want to get to, and Docker Slim helps you there. With seccomp, though, there are different levels of filtering: the syscalls themselves, and then the syscall parameters. And with Docker Slim doesn't do parameter filtering. It doesn't define filters for the syscall parameters. It just focuses on the syscalls. But either way, seccomp is limited in its design in terms of what you can do with those filters, because it can't really do deep inspections on parameters. So if you have a pointer, you can't really go to that pointer and look at a subfield. So there's only so much you can do with seccomp. But that's one of the things you can get. So if we can also look Docker images. There we yeah. nginx. We have those two images, and we can we can run them. So let's see, Docker run its nginx Still need ports. Okay, nginx is up, and if we go to another terminal later, and if, oops, here. Okay, what was that combination again? I to make the font bigger.
Control Shift plus.
Control Shift plus. Control Shift plus. Okay. All right. Good. Perl HTTP localhost, and we get that. You know, we get the standard welcome to nginx, and if we look at Docker PS, we have nginx Slim running, and yeah, listening on port 80. Oops. And we can kill that. Let's take a look at all right. This is one of the things you end up with. There's the artifacts Docker Slim generates. They usually live in this temporary directory, but you can copy them. There's a copy metadata flag, but I'll just look at the artifacts there. So if we look at nginx seccomp, this is what you end up with. There's there's an allow seccomp profile with all of these syscalls in that allow list. And then let's see.
So there are a couple of questions as well. Can we build the image from? I mean, can we use Docker Slim directly on a Docker file? I mean, you used a target as image, right?
Mm-hmm.
So
Yep.
can we have a Docker file and it will optimize that?
There's a way to do it. You still end up with a fat image, but you can use the build command, and then there is a Docker file flag to it. So you point at the Docker file, and then you need to specify the context directory as well. So the last parameter needs to be the context directory. So if your Docker file is in the current directory you're in, you just do it like this, and then it'll look at the directory you specified. It'll look for the Docker file name that you provided, and then it'll build a fat image, and then it will optimize it, so you'll end up with two images. There's eventually there'll be a more optimized way to do it, but yeah, there's a way to do it like that.
And another question is like, is there a possibility for Docker Slim to show the recommended actions on the Docker image first and then build it later on?
So there's in terms of removing stuff and all of that.
Yep.
Yeah. So Docker Slim it has the lint command, and it does something similar, but not quite. It looks at the Docker file, and again, the ultimate goal there is to be able to point it at existing Docker images. But it tells you kind of problems with your Docker file or a Docker image composition, and then based on that, you can make enhancements. But I think what you're asking is closer to the optimizations that Docker Slim does, and for that, the goal for Docker Slim, maybe it'll do that as well, but first it'll probably show up in the Slim.AI portal, SaaS. So there, and most likely it'll happen based on like a couple of things. It'll run xray, and then it'll run the profile command. And the profile command is like the build command, except that it doesn't generate the optimized image. And then it'll combine the information for the results for those two, and it'll show you, hey, this is what we're going to remove. But actually, that's a good opportunity to show the Slim SaaS in action. That tells you when you tells you the difference between images, and that's one of the cool things about it, where you can it tells you the differences between the different versions of the same image, or the fed image and the optimized image as well. So let me quickly go there, and I'll need to switch to another screen share. All right, window. Okay, so here I'll search for nginx. I'll use that as an example, but the same applies to looking at fat and optimized images. So here I search for nginx, and it, you actually end up with a multi-registry search. So it searches Docker Hub, Quay, Microsoft Container Registry, and there's going to be a few others. And then I'm looking at the nginx image. So one of the cool things, and this is powered by xray. So one of the nice things there is that it gives you kind of a visual way to navigate what you have in the image. So we're looking at the nginx image, and I can search for stuff. It's basic search for now, but I can look for all of those license files, and it gives me a nice container startup information where I can go to my startup entry. I can look at the metadata, and I can actually look at file content. So right there, I'm looking at Docker dash entry point dot shell, and I can inspect what's going on there. But so you can do a few things, and it also shows you the reverse engineered Docker file that I mentioned. So it's nice. But another nice thing is that you can diff with another version. So like I mentioned, it can be another, it can be like another version 1.2.21. So I'll use that. It can be another, it could be one of the previous releases, or it can be an optimized image. So let's see what we get. Yeah, I'll pick a different one. And I'll reload. Take two. Alpine. Alpine is nice as that because it gives you a nice view, a few different things. Come on.
It's loaded for me if you want me to share that.
Oh, you did that too?
Yep, the difference. I was doing in the background.
Okay. Yeah, actually, that's a good idea. Uh, Go ahead. That would be even better. Yeah, I'm using the dev portal that sometimes breaks, and you're using the production portal. That's the difference.
Okay.
So using portal.slim.dev, and I'm using the one of the dev portals. So right there, you have different colors that kind of show you what was deleted, what was added, and what was changed. Blue is the files that got changed, and red stuff that was deleted, and green stuff that was um, added. So when you're with the fat and optimized image, you'll be able to compare them the same way, and you'll see that, oh, those files were added. Well, actually, with the optimized images, everything will be removed. Everything will be kind of removed, because it's not just a new release, it's an optimized image based on the fat image. And if you do a diff with another version, like 1.20 or 1. So if you scroll up, yeah, yeah, just start typing 1. Oh, 1, yeah, that one, yeah, yeah, that works. And nginx.
Okay,
Okay.
it's
And if you pick an interesting file like nginx, right? Oh no, I keep scrolling. Mime types. If you click on mime types, yeah,
this one.
yep. If you click on it, you'll see basic metadata difference, and then you can click on file contents, and there you'll get a file diff, and you'll see how that file changed. So there, you ended up with application WASM as the change in the file. So that kind of goes back to the original question: is there a way to show what changed or what will change? And this is an example of a way to show what changed. And the same thing can be kind of as an enhancement, where we'll be able to show all of that before before something is optimized.
Interesting. A couple of more things before we end. First is like the X-ray command that you told that we can run from the CLI as well.
Mm-hmm.
That gives you the file explorer thing, right? The file explorer stuff. What all files are there in the image?
It'll give you the raw information, so you'll get a whole bunch of stuff printed to the screen, and then you'll also get a command report, a JSON file that includes the information about the image that you inspected. If you specify, by default, you get the top changes, but you can get all changes. So you need to specify dash changes all, and then you'll get the information that powers that file explorer. In Xray, you don't get that file explorer, at least for now. There'll be a command line, kind of a terminal UI version for it, but you do get the data, the information about the files that were changed in each layer, and the changes that happen. You can also extract data from your image, so kind of like a cat for container images, or a grep for container images, where you can say, find me a file in an image with this data in it. So there's a lot you can do. It's just a little more to do but the command line flags and all of that, and no terminal UI for the file explorer.
Okay, cool. That was pretty interesting and insightful, details. And Slim.AI, I think, is in early kind of access. So, how can the community reach out to you for the early access, or is it something limited, or what is the criteria?
If you, am I okay? I'm sharing the screen, right? You go
Mm-hmm.
to Docker Slim,
Mm-hmm.
and right there, and there's that button, Try Slim SaaS.
Okay.
You can install Slim locally, or if you click, when you install, click on install, you have a few different options to install.
Mm-hmm.
Or you can click on Try Slim SaaS. It takes you to the portal. It fills in the invite code field, and then you log in with GitHub, GitLab, or Bitbucket, and that's it.
Okay. Cool. That is cool. So you all can try out the Docker Slim SaaS, and see how it works, how the comparison is there. So from the registries, can we add our own Docker custom images to compare in the SaaS?
Yeah. Actually, if you portal is still sharing. But that's one of the good things, extra things you get with the SaaS. You get to connect your own registries, and for example, I started by searching for nginx. When you add your own registries, it searches in your registries as well, so you can add your authenticated Docker Hub account, GCR, ECR. And
Awesome.
then you can do everything but the container images you're connected.
Awesome. So that's pretty much it, everyone, that we had for today. And thank you so much, Kyle, for your time and telling us all about starting from Docker files, and to Docker Slim, how it works, some of the commands, and obviously the Slim.ai, the UI, what all things you can do, the comparisons, file comparisons, the
Mhm.
comparisons between different images. So a lot of things looks promising, and I think people can readily start using Docker Slim. Just do the X-ray, just do the lint, and see what all things are there, and just try to run Docker Slim on the images and see where it works, where it breaks, and then try to fix it. So that would be pretty interesting for some of the folks who are watching and will be watching later. I'm definitely sure people will try out on some of their current images, which they have, especially in the data science field, for sure, because they are in GBs. So that is worth trying over there.
But not
So
only, even basic web applications can be pretty big, like 1
yep.
gig, 2 gigs. It's pretty common.
Yep. So, yep, that was really insightful. Thank you so much, Kyle, for sharing all that knowledge with us. And thank you so much, everyone, for tuning in today. After this session, there is another session that I'm doing, which is on chaos engineering, where I'll be speaking about the basics of chaos engineering, exploring the terminology. You can tune into CVO channel for that. I'll be doing on the CVO channel as a CVO webinar. So that's why we are kind of wrapping this up. So thank you, Kyle, for so much for your
Thank you.
time and the stream, and thank you so much, everyone, for tuning in. Do not forget to subscribe to the channel and share about the stream, and tag Kyle, and also let us know how you plan to use Docker Slim, or how you used Docker Slim. Thank you so much. Bye all.